Good morning to one and all. Myself Divya. Today my concept video topic is MOSFET, metal oxide silicon field effect transistor. What is MOSFET? Metal oxide silicon field effect transistor, commonly known as MOSFET, are electron device used to switch or amplify voltage in the circuit. It is a voltage control device and it is constructed by three terminals. The terminals of MOSFET are named as source, gate, drain, and body. In this MOSFET, the three terminals are used such as source, gate, and drain. It is similar as transistor such as base, emitter, collector. So MOSFET construction is, see here we can see that it is NPN MOSFET. How we can decide is the P region is substrate. It is the also known as body. It is doped by N plus. So it is doped by N type, and here we have left side is the source and the right side is the drain, and the middle part which is connected to the oxide, so it is nothing but SiO2 silicon oxide is placed, and on that it is noticed, it is declared as gate. So this is the normal construction of MOSFET. So MOSFET is nothing but the uh, metal oxide silicon field effect transistor. So first we need to develop the MOSFET, develop the substance. In that body, it is doped with the N type or P type. If we take the substance as N type, then it is doped by P type. If it is P type, and it is doped by the N type. And in the gate and the below substance, the middle layer is considered as oxide. We use silicon oxide in between. And P channel P channel, the P-type semiconductors form the basic of the MOSFET. The two type of base are highly doped with the N-type impurities, which is marked as N plus in the diagram, from the heavily doped region of the base. The terminal source and the drain originated. The layer of the substance is coated with a layer of silicon dioxide for the insulation, and a thin insulated metal plate is kept on the top of the silicon oxide, and it is act as a capacitor. The gate terminal is brought out from the thin metal plate, and a DC circuit is then formed by connecting a voltage source between these two N-type region. So here the P-type channel is nothing but P is the P-type material is this semiconductor. It is the base of the MOSFET. In that we dope by the N-type material, which is N-type impurity. Impurities are doped as we seen in the figure, and here the base is at the heavily doped one N type is known as source terminal, and the other N type is known as the drain terminal. And on that gate and in the substance, the middle metal layer is formed, that is silicon dioxide. It acts as an insulator and it acts as a capacitor. The working principle of MOSFET. Working principle of MOSFET are: when the voltage is applied to the gate and the electrical field is generated, that changes with the width of the channel region where the electrons flow. The wider the channel region, the bigger the conductive force. So here this point is saying but nothing but the if the region is wider, if the channel is wider, the conductivity of the device is also more. If it is less or it's narrow, then it will conductivity is also less. So here we can see in this diagram or in this picture, it is N-type MOSFET and here P-type MOSFET. So these are declared by N channel and P channel is nothing but by doping the N-type impurities or P-type impurities. If it is N channel, it is doped by the P-type impurities. If P channel, it is doped by the N-type impurities. MOSFET types. Classification of MOSFET size is MOSFET based on the construction and the material used in the given Flowchart. MOSFETs are two classes: enhancement MOSFET, and depletion MOSFET. Each class is available as N channel or P channel. Hence, overall, they are tallied up by the four MOSFET. MOSFET are divided into two modes: enhancement and depletion. In the enhancement, P type channel, N type channel. In depletion, P channel and N channel. Here we can see that construction of enhancement mode and depletion mode. The major difference is in the enhancement there is no bridge or the connectivity form, but in the depletion form there will be a connective connection. See, as in the picture also we can see that the lines are some divided, but here we will have the straight line in the depletion. So connected bridge is there. Here there is no connection in between them, and the middle terminal is the gate, and the upper is the drain, and the lower is the source, and the region is substrate. So depletion mode and enhancement mode. Depletion mode, when there is no voltage across the gate terminal, the channel shows maximum conductance. When the voltage across the gate terminal is neither positive nor negative, then the channel conductivity decreases. Enhancement mode, when there is no voltage across the gate terminal, the device does not conduct. So when we see depletion mode, there will be a conduction decrease in conduction, but in enhancement mode there is no conduction at all. When there is maximum voltage across the gate terminal, then the device shows some enhanced conductivity. The N channel MOSFET are abbreviated as NMOS, are symbolized respectively as in the figure. As we can see, this is N channel MOSFET and this is P channel MOSFET. So here they have the connectivity between the substrate. Here we have there is no connectivity. So no connectivity is known as enhancement, and complete connectivity is known as depletion. Similarly, the P channel MOSFET are abbreviated as PMOS. Operating region of MOSFET. A MOSFET is seen to exhibit three operation region. Here we will discuss about the region as cutoff region, ohmic region, and saturation region. Cutoff region. The cutoff region is the region in which there will be no conduction. As the result, the MOSFET will be off. In this condition, the MOSFET behaves like an open circuit, and the cutoff region is nothing but there is no conductivity at that point. It is known as cutoff region, where it is act as an off state. It acts as the open circuit. Ohmic region. Ohmic region is the region where the current increases with an increasing in the value of VDS. So ohmic is nothing but the the current increase region. When the MOSFET are made up to the operating in the region, there are used as amplifiers. So ohmic region is operated as the amplifier. Saturation region. Saturation is nothing but the region of the MOSFET has their IDS constant at the increasing in VDS. When there is increase in VDS also, at particular point it acts as a constant IDC. So occurs once VDC exceed the value of the pinch of voltage VP. So when the VP pinch of voltage is exceeded, we enter into the saturation region. Under this condition, the device will act as a closed circuit through which the saturated value of IDC flow. As a result, the operating region is chosen whenever the MOSFETs are required to perform switching operation. So when VDC is increasing also, the IDC will stay at the constant stage only. The saturation is nothing but the complete at the end point where it reaches to the high level. The MOSFET applications are radio frequency application using MOSFET amplifier extensively. MOSFET behaves as a passive circuit element. Passive circuit element is nothing but passive elements are resistor, inductor, and capacitor. Power MOSFET can be used as a regulated DC motor. MOSFETs are used in the designing of chopper circuit. Advantages and disadvantages of MOSFET. Advantages of MOSFET are They are operating at the greater efficiency at lower voltage, and absence of gate current result in high input impedance, producing high switching speed, whereas disadvantages are unreliable to damage by the electrostatic charges due to the thin oxide layer. Overload of voltage make MOSFET unstable. Thank you.